Hello guys, welcome back to Tronic Synergy. So the past seasons we have been saying that we want to start building an ALU. So we want to start building that ALU, but first I'll start by constructing a logic unit. Then next time I'll make an arithmetic unit. Then I'll combine them together to make the arithmetic and logic unit. We can do maybe a 8 by 1 arithmetic and logic unit by the end of this season. So this is a logic unit. I've decided to go big, so as you can see we have some number of ICs there. This is the main IC. This is a multiplexer. It's a 4 by 1 multiplexer, so it has two 4 by 1 multiplexers. One is on the top side and the one is on the bottom side, so I'm using the one on the top side. Then I'll combine it with the bottom side when we are done to see how we can make an 8 by 1 multiplexer using these 4 by 1s multiplexers. So there's a logic unit, meaning that it will only be doing logic operations like AND, OR, NAND, NOR, XNOR, and maybe we can also do not A, not B, things like that. So we are going to do that, and so I decided I wanted to show you the construction of how we are going to build this. This is a big circuit, so it requires some patience, and all things will be well. So these times I always do when I'm doing big circuits like this. I always want to test everything every step of the way, because there's a time I was building an advanced motion sensor, and I decided that I want to connect everything, and then I'll power it. Then it will be working the way the schematic was. So it really cost me, because when I was done, and it took me around some few hours there. When I was done, some things were not right. The comparators were not communicating well. The LEDs were just flashing here and there. So it made me reconstruct it again, and then try to see where the problem was. So it's always good building circuits which are big like this. Start small, test everything every step of the way, and when you are done, everything will be cool. So it saves time and accuracy. So as I said, this is a 4 by 1 multiplexer. It's a 74153 SN74153. It's a dual max circuit, 4 by 1 max circuit. So on the top side, I'm using this top side multiplexer, which pin number 9 is the output. You can see this LED output. Then pin number 10, 11, 12, 13, yes, 13, and I think 14. No, 13. So from 10 to 13 are the data lines of that multiplexer. Then 14 and pin number 2 are the select. So 14 is 0, or let's say S0, like this. Then pin number 2 is going to be S1. Yes. Pin number 15 is the enable. This multiplexer has enable, and it has an inverted connection there, meaning that when it is 0, it's going to enable the circuit. When it's given 1, it's not going to give the output, because it's connected to output. This is how it's connected. Now, let me just show you. This is how it's connected. So if this is the output, this is the output line, this is the enable, so they are connected together, and in order to give the output, there's an inverted input there. Then this is a logic AND gate, yes, and that's the final output. You can just X. So this is how it's connected. So it means that when enable is 0, it's when it's going to enable this, because 0 will be inverted to be 1, and if when it aligns with the output, then it's going to give you what y is. So when it is 1, it's not going to enable this, and it's not going to give any output. So that's basically how the enable is connected to on this integrated circuit. So yeah, so the first operation that I've started with, this is a 7408 AND gate. It's an AND gate, and it has two inputs, A and B. I'll rub this because we don't have four inputs. We don't have four inputs like A, B, and C and D, but we can say that this first one, A, we can say that A, let me just put A will be AND operation. AND operation. So A has only two inputs, has only A and B. So it's going to be looking when A and B are combined and giving the output. So these are the A and B, and they are passing through this AND gate IC. So looking at them, you can see that A is on, B is off. So A and B should be 0. So we expect that this jumper is 0 because it's from the output. A and B is 0 because both the inputs have to be on in order for the AND gate to give a 1 output. So when it enters here, this is D0, this is D0, this is D0, D0, this, okay, let me just show you what I mean. So we have let's use D. We have D0, we have D1, we have D2, and we have D3. So when it enters the D0 section, this is a data line of D0. When we want to select that on our multiplexer, we'll have to put 0, 0, 0, 0 at the select. You see this select? It has three LEDs, but we are only going to use these two. First one, the other one we'll use it later when we are done with making the circuit. So when it enters the D0, means that we have to put 0, 0 at the input section for us to select it and check what is that operation and what's the output of that operation. So so yes, so our circuit is 0, 0. Let me check. Yes, it is 0, 0. And because A and B is 0, then it's going to give you 0. If A and B will be on, it means that AND gate will give 1. And when that 1 enters D0, then when you select 0, 0, it's going to show us what's the output of that section. So when we put 1 here, we expect that the LED will be on, meaning that the AND gate has given a 1 because both the inputs are on. So let's put it on and check. And yes, once it is on, the LED is on, meaning that A and B are, when A and B are both combined, they are both 1. So meaning that it's going to show you the output of that AND gate, and the output of that AND gate is 1. So meaning that it has given the 1 output. So yes, so that's the foundation, and we are going on making we have this is an OR gate. Here we have a NOT gate. This NOT gate will help us to make, like, when this is an AND gate, so when we pass it here, it's going to make a NAND gate. So NAND gate operation will also be there, and this is an OR gate. When we pass it there, it's going to make an NOR gate, and that NOR gate will be in the multiplexer. Then finally we have a 7486. It's an XOR logic gate. We are also going to add it in our multiplexer. Yes, so that's the foundation. Yeah, I'm going to put other videos on how me making this, and we are going to follow everyone step by step until we are done with making our 4x1. I've put 3 LEDs here on the select, meaning that I'm going to combine these two multiplexers to make 8x1. I want to fully extend to combine all these multiplexers to make an 8 by 1, meaning that it will have 8 inputs. The select should be 3, and it will have the circuit will be controlling, will be checking A and B in 8 different possible ways. We have AND gate, OR gate, NAND gate, NOR gate, XOR gate, Xnor gate, not A, not B. So those are the logic operations that we'll be doing, and yeah, so stick by for more videos, and yeah, hope to see you next time.